Okay, so I'm going to talk about the boring bit of the DTT network, the receiver at the end. I'm going to talk about even the most boring part of that is testing it. So the reason I'm talking about it is because the receiver's at the end of the chain. And it's the thing that if you get that wrong, all that great content, those huge transmitters are all wasted. Now we test for probably 40 or 50 countries and experience of DTT rollouts, and getting the receiver wrong, not getting it tested properly, or the supply chain isn't ready, the receivers aren't there, is a very common problem. So I'm going to talk about how you can help mitigate these kind of issues and the things you can do. So the consumer is expecting to have a quality experience of receivers. They want to go into the retail outlet to choose different receivers, one they want, them to be low cost. They expect when they buy that receiver, it actually works. When they turn it on, they get all the channels they're expecting, the audio and video works, it's reliable. For the network operator, the important thing is support network changes. And what I mean by that is networks evolve, new MUCs are launched, pay TV operators come up. And if that receiver is not working correctly, suddenly there is a problem. So I'm going to talk about the supply chain. So supply chain is set-top box and IDTVs, integrated televisions. The reality is most set-top boxes are made in China, and they have variable quality. Not because the Chinese are bad people or the people making set-top boxes are bad, it's because they don't make much money and they have to limit the investment they make. And testing and getting the receiver right, they try and reduce those costs. So generally, if they can avoid testing or conformance or a test lab, they will, because it costs money. So when you're building a receiver for DTT, you're building it to a spec. Now DVB is it's like making a cake. It's a recipe. You're taking different ingredients from different DVB specs and making it into a country profile. And the thing is, each country profile is different. France, Germany, UK, Spain, whichever country it is, its DVB is implemented differently. It's the same for Turkey. So when you're testing a receiver, you're testing against that profile. You can't test for DVB-T, DVB-T2 as such. You can only retest against a profile of that spec. So what's the point of testing receivers? Why do you do it? Why do you need conformance? Why do you need labs, test labs, etc.? The reason you do it is because unless you do that, the receivers won't work. Some will not. And that means when they don't work, there's damage to the DTT platform brand. People share things on social media and say, well, I've bought this new DTT set-top box, it's not working correctly. That information is shared and it's not good for the platform. There are things that are important as well. For example, if we're using HBB-TV, which I know there's a presentation later, and I'll talk a little bit in a moment, getting those HBB-T apps is quite difficult to work on receivers, and they need to be conformant. The last point is a thing called over-air download. This is where you download new software into receiver. So if something goes wrong in the network, you need a new feature, you can upgrade the software. If that feature doesn't work, then you can't do it. So you need to make sure that works correctly. So what are the problems you see? Now, we've tested hundreds of set-top boxes and the kind of problems you see. RF sensitivity is an issue, particularly on indoor modes. If you've got indoor reception modes, making sure that the sensitivity is good is very important. We see things like problems on borders. What happens when you receive a multiplex from a neighboring country? How does the receiver react? Channel order, changing bit rates in video, we see problems with that. Audio channels, things like faulty subtitles, that's a common problem. Most of these problems are actually around the software in the box, because these are software platforms. So talking about some of the testing features. When we're testing set-top boxes, most people think about the hardware features, the RF, the front end, the radio part of the receiver, the input, the outputs, EMC, safety, power consumption. Those are important things you need to test. But actually, where most of the problems are in the software of the box. Because everyone is customized for every different market, there are many different platforms. Things like service presentation. This means, are the channels in the right order? Is the information displayed correct? Is the local language characters displayed correctly? The font correct? Things like time, video and audio, the EPG. EPGs are implemented very differently from country to country. And then there's things like HBB TV and over download. So for these kind of front-end tests, hardware tests, basically a test lab will buy a big fancy piece of kit and install it, you know, a couple $100,000 worth. For the software features, you need a test suite. A test suite is the ability to test specific features for that country profile. For overhead download, it's very specialized, you need specialist tools. And for HBB TV, you need a test suite as well. So I'm going to skip these 2 slides because they're quick, but I'm going to skip to HBB TV. Briefly, what HBB TV is, for those who don't know, is a hybrid technology which allows the broadcaster to transmit a web URL in the broadcast stream and means the set-top box can access online content. It's very important because it allows the broadcaster to add to his profile, to add to his portfolio with additional channels and information. So the reason why it's important is because what we care is about interoperability. You want the HBB TV application to actually work on the receiver. Now this is a kind of very simplified diagram of a receiver. You've got an HBB TV app, a browser, some DVB middleware, and some glue code. Glue code is what puts the browser onto the DVB platform. The HBB TV app is running a JavaScript API. It's a JavaScript application typically. Now, there's 2 or 3 browsers in the world, Opera, SPL, Ant. They're quite common. But actually, when that browser is put on the platform, it's actually the glue code which goes wrong. So we see problems at Test House is where the browser is integrated into the platform, and there's something wrong with that glue code implementation. So that's why you need to test every platform to make sure it works, the HBB TV app. So typically, these kind of applications tend to be in the pay TV operator world. Pay TV operator have applications interactivity. The pay TV operators normally have 1 or 2 set-top boxes, and they make sure they work because they have the resources and time. If you're a broadcaster in a free-to-air environment, you have no control over the receiver. You don't control the TV, you don't control the set-top box. But if that application doesn't work, it's the broadcaster that gets blamed because you're watching some content and you're in that content world of the broadcaster and it goes wrong, you think it's the broadcaster's problem. So the problem for HBB TV is how to make sure it's going to work on all these different receivers. Now, this is a complex diagram, and what it's trying to say is there is a logo, official logo for HBB TV, which is a great thing. The trouble is that HBB TV logo means nothing to consumers, and no set-top box manufacturer, or hardly any, put that on the receiver because it has no value. So none of the manufacturers have to test right now. So when you buy an HBB TV receiver, it doesn't have to be tested. There's no quality control necessarily. So talking about different approaches, every country is different, has different approaches. I'm going to give you some different ideas that can be used for different territories for how to do testing on the receivers. One option is to do nothing. Just let the market provide receivers. Let's see what happens. That's good because you get lots of receivers. The bad thing is they don't all work correctly. Consumers get upset. And as network operators, you'll have problems because you can't add things to the network. Say you want to make a video resolution change. This is a very common problem. We've seen it in Germany recently. They changed from a normal multiplex, statistical multiplex. Suddenly some receivers broke. Now, that's because they hadn't really been tested properly. The second one is a light touch approach, which is self-certification. This is where the manufacturer has a report, gives it to some authority and says, yes, we've passed the test, we're all very good, thank you very much. It's a bit like asking your kids to mark their own homework because they're going to say, of course, yes, it's very good. This is better than doing nothing, but has issues. There's one country I can't really name at the moment. They have a self-cert regime, and they're having lots of problems with indoor reception because those receivers aren't good enough. They haven't been tested correctly. The last way is to have full control, where you have a test center, a test lab, And every receiver has to go to that test lab to be tested to get a report. This ensures quality. It means sure the applications will work. It means that platform upgrades can occur. The downside is it takes longer for the receiver to get to market. So this is an interoperability ecosystem, and it really talks about the kind of things that need to be done. But the important thing I want to focus on is around how you enforce a receiver that works. And it's done in different ways in different markets. Some markets, you have a white label system where there's a website which says, these are the recommended receivers. We recommend you as a consumer buy those. Some places you have a TML, a logo, a trademark. So unless you've done the testing or been to the test lab, you don't get the trademark. In the UK, it's Freeview. You have to go to a test lab like us to get tested to get that logo. And that works very well if the logo is strong. Some markets with more control have type approval. Every receiver has to go through a type approval to be sold on the market. The important thing is actually this is really quite hard to do. If you have a logo system, you have to communicate to all the retailers, you have to communicate to consumers. It takes money, time, marketing budgets, and it's not easy. And a lot of countries get it wrong. It doesn't work. There are a number of logo systems which have just failed. So this is about supply chain timings. This is the other issue that we see, is there's not enough time. It takes time to get a receiver, to test it, to build a test lab, and then to make sure that receiver works. It takes a few months. Often we've seen a stage where networks are launched and the receivers are just not ready, particularly IDTVs. IDTVs have lead times of up to a year sometimes in terms of design to actually shipping, because these are big platforms that launch across the world. So my advice for rolling out a network is you take the supply chain very importantly, you communicate with it, you make sure it has the test materials, there's a test lab, and they have time to get their product ready so when the broadcasts are launched, those set-top boxes will be ready for the consumers to buy and they'll work. So this is an example of a test house model. It's very, very typical. Basically, you go through a test lab, you can pass, you go to some authority, they'll give you a logo or a type approval. If they fail, they typically go through a debug cycle. Now, it's important you have that capability where the manufacturer can go to a test lab to make sure it can run through the problems, or you get some test materials, a test suite, so they can fix the problems in-house. Okay, so that's my presentation. Thank you very much.